All right, everybody, welcome to the video here for lesson number 9, solving simple radical equations. So for number 1, there's two equations that I want to see if you think are true for all values of x. And the answer for both of them is yes. And the reason why the answer is yes for both of them is the square root and something squared, they're opposite operations. Same thing happens with cube roots and something cubed. So we could say yes because both show opposite operations. Well, let's move on to number 2, and this is really like the meat of the lesson. So for number 2a, the first thing I want to do is isolate the square root. So I want to divide both sides by 2. That gets rid of this 2, leaves us with the square root of x plus 3 equals 3. If I then square both sides, I get x plus 3 equals 9. Subtract both sides by 3, and I get x is equal to 6. X equals 6 checks. If you plug that in, you get the right answer. If you were to graph both sides of the equation, like set this side as y1, this side as y2, you'd see they'd intersect at the x value of 6 as well. For part B, if you add 6 to both sides, we get the square root of x plus 3 is equal to 9. Square both sides, and I get x plus 3 equals 81. Subtract 3 from both sides, and I get x is equal to 78. Again, this checks. If you plug in 78, it works. If you do y1, y2, and check it that way, it also works. For part C, if you square both sides, just like the one we did in class, you get 2x minus 3 is equal to 10 minus x. Some causes you'd have to do a little bit more algebra, but nothing you can't handle. If you add x to both sides, you wind up getting 3x minus 3 is equal to 10. Add 3 to both sides, and you get 3x equals 13. Divide by 3, and you get x equals 13 over 3. Now, not as easy of one to check, but it's still checkable, right? So you can plug it in the calculator. You're going to wind up getting 4.3 repeating as your answer on the calculator, or you could plug it back in. You're not going to get a nice number there, but something that you could just evaluate in the calculator. For part D, if you square both sides, you get x squared minus 6x equals 16. Subtract 16 to the other side, and you get x squared minus 6x minus 16 equals 0. Factor, right? So what multiplies to make negative 16 but adds to make negative 6, and solve. Here you get two answers. Now, a lot of times when you get two answers, one of them won't check, but in this case, they actually both check. So if you were to graph this in your calculator, you're going to get something that looks like this. You're going to have a value that looks like that, and then you're going to have a line that comes across. So you're going to have two answers. Part E, if you subtract 8 to both sides, you get the cube root of 5x minus 3 equals negative 2. And normally at this point, if it was a square root, we'd say that's no good. But with cube roots, it's okay to be negative. So if we cube both sides, we get 5x minus 3 is equal to negative 8. Add 3 to both sides, and we get 5x equals negative 5, or x equals negative 1, which checks. If you plug it back in, you wind up getting the cube root of negative 8, which is negative 2, and that works. Same thing for f. We'll cube both sides here. So we have 9 minus x is equal to 6 cubed, which is 216. Subtract 9 from both sides. I have negative x is equal to positive 200, and having a brain fart here, 207, sorry. Negative x we don't want, so we make it positive and change the other side. Also works, right? If we do 9 minus negative 207, it becomes a plus 9, giving us the 216 that has a cube root of 6. Number 3 says, solve the equation x squared plus 9 underneath the square root equals 5 algebraically. So to do that algebraically, we'd square both sides. So I have x squared plus 9 equals 25. Subtract 25, I get x squared minus 16 equals 0. And then it becomes factorable to x plus 4, x minus 4, and I get two answers, negative 4 and positive 4. Another way of solving that would have been setting it equal to x squared. You would have got x squared equals 16, square root both sides, and just remember when you do that, you get two answers. So if I was to graph this, right? If I was to graph this, I can make y equals 5 as one of my graphs, so that would be g of x. That's what it told us above, right? And then you're going to see a parabola looking thing that comes down like this is how that's going to look. It's actually not a parabola, but it kind of is. And you're going to see 2 points of intersection. One is going to be at -4, 5, and the other one is going to be at 4, 5. Both of those you can get right in your calculator. For number 3, we can cross multiply. So we get 3 square root of x plus 9 equals 12. Divide by 3. And we get the square root of x plus 9 equals 4. Square both sides. X plus 9 equals 16. Subtract 9. And we get x is equal to 7. 7 works if you plug it in. So we're all good, right? Keep checking those solutions. The last one says, and this is kind of like a challenge question, show that a minus b over the square root of a minus the square root of b is equal to square root of a plus square root of b is an identity. So this kind of brings together something we did in Unit 1 and brings it together with the concepts from Lesson 2. That's something that will happen throughout this entire school year. So a couple things we could do. We could cross multiply. So to have the square root of a minus the square root of b times the square root of a plus the square root of b is equal to a minus b, right? Make that over 1, do my cross multiplying. Then hopefully you notice that these two terms on the left side, well, they're conjugates, so we actually don't have to do a lot of work here. We just have to square the first term and the second term, and then see that that becomes just a minus b, because when you square a square root, it just becomes the radicand. And there we go, it's an identity. Now, all of this part where a is greater than 0 and b is greater than 0 and a is not equal to b, those all have to be there to just verify that this is a valid equation, right? If that wasn't there, it might not be in a valid equation. And that's it. Hopefully that was a nice short and sweet homework for you. Hopefully this video helped. All right, if you're liking these videos, keep watching them, tell your friends that they're helpful, right? And that'll be good for everybody. All right, good luck with your homework, and I'll see you all tomorrow.